Attempting to hit an armored truck speeding across the desert a mile away is a problem of pure physics, made nearly impossible when you're doing the math under enemy fire. For decades, the standard tool for solving these battlefield problems has been the 84mm Swedish Carl-Gustaf recoilless rifle. Its crews usually just call it the Goose or Carl-G. The system functions as a modular multi-tool utilizing 11 different specialized unguided rounds. For example, the MT-756 uses a tandem warhead to punch through concrete walls and detonate inside a bunker. When facing infantry in the open, the ADM-401 round turns the launcher into a massive shotgun, saturating a trench or a tree line with 1100 small metal flechettes. Against stationary structures or targets closer than 500 meters, this versatility makes the unguided Carl-Gustaf an unmatched infantry equalizer. However, the modern threat often sits much further away. In many theaters, a squad might find itself staring at a target over 2000 meters out. At these distances, unguided rockets become unreliable. A moving vehicle can easily displace while the round is in flight, and the moment the squad fires, they reveal their exact position to the enemy. Heavy guided missiles are designed for these long-range strikes, but they are too heavy for standard patrols. This creates a range gap, a dead zone between 1000 and 2500 meters. It's too far for unguided rockets, but the targets don't justify a multi-million-dollar missile. Saab's first attempt to bridge this gap involved the FCD-558, a smart optic designed to solve the math of unguided fire. The sight uses a protocol called Firebolt to create an electronic handshake between the launcher and the round. Firebolt measures the exact temperature of the propellant inside the chamber. Because the propellant temperature changes the burn rate and the muzzle velocity, the optic uses that data to adjust the digital aiming point with high precision before the shooter pulls the trigger. But there is a ceiling to this technology. Even with the perfect launch math, the round remains unguided once it leaves the tube. The optic cannot compensate for a sudden crosswind or target vehicle that rapidly changes speed while the round is in mid-air. The more complete solution is the Guided Multipurpose Munition, or GMM, co-developed by Saab and Raytheon. The GMM is a 15-pound smart missile, engineered to fit inside the standard 84mm barrel of the Carl-Gustaf. Its semi-active laser seeker tracks a reflected laser beam, steering the missile towards that dot. It also uses a soft launch system. A small booster pops the missile out, and the main motor ignites safely away from the operator. This combination of precision guidance and low-impact launch changes the physical geometry of an engagement. This technology enables lock-on after launch, or LOAL, capability, which significantly improves infantry's survivability. Because of the soft launch mechanism, a gunner can fire from deep inside an enclosed room without the backblast overpressure injuring them or destroying the building. While the gunner stays hidden, a second soldier potentially a mile away can use a laser designator to guide the missile to its target. By separating the act of fire from the act of aiming, the system functions with new kind of logic. The gunner launches the missile and the spotter directs it to the impact point. Traditional unguided rounds require a direct of-line sight and are generally limited to around 400 meters when engaging a moving vehicle. In contrast, the GMM can defeat up-armored targets at 2500 meters, often without the gunner ever seeing the target they hit. The GMM doesn't replace the original 11 unguided rounds, it simply adds long-range precision strike capability to the existing multi-tool. The answer to the modern range gap wasn't building a new weapon, but taking a reliable 1940s platform and giving it 21st century eyes.